would ignore you.
Okay. Water is so good. Water? You know what's good?
Okay, so today's lesson's called isometries. It's just a fancy word that means the transformations that don't change their size or shape. Okay, so basically it just keeps everything congruent. And it's kind of a review in a sense because it's the things that we've been doing already have been isometries. So what are the things that we have been doing? We've done 3 things so far. Rotation was yesterday. Yeah, translation, which is a fancy word to mean what? No. Yeah, moving it over, but it's a slide. And there's one more.
Transformation?
No, these are all transformations, but
Rotation. Reflection?
reflection. What's another word for reflection? Flip. Okay, so we're adding one more. It's not really new exactly, but the book calls it a glide reflection. It's probably one of those things we'll only see in this book, but it's okay. Glide reflection. What do you think a glide reflection might be?
You flip it and you move it a little bit.
Yeah, it's just by glide it's like slide. It's a translation followed by reflection. So, for example, if I have this image and I translate it, it like move over here. And then if I flip it over this line, it would go down to here. So, it's just a translation followed by a reflection. So, glide, reflection. Still an isometry because it's still the same shape and size. So what is not an isometry? I don't know if I mentioned this the other. We're not really doing that today, but did I mention this word on Monday?
I don't know. Dilation.
Maybe I probably didn't mention it. So where have you guys heard the word dilate before?
Your eyes.
Your eyeballs. What does it mean when they dilate your eyes?
Big.
Your pupils get big. So that's kind of what it means. It means kind of like blowing up the image or shrinking the image. Okay, but it keeps the same, still similar image, but it just makes it larger, bigger. This is not an isometry, so this will not be on today's. But that'll be like Fridays, I think. It's not bad. That was a little bit. It's easier than rotation. Let's put it that way. Okay. Yeah. So these are the 4. These 3 we already did. This one's just a combo of these 2. Okay. So let's take a look at 1 through 6 here. It says, name the type of transformation illustrated by each isometry. So these are kind of like our 4 options. Identify any transformation that is not an isometry. So at least one of these is not going to work. Not going to be an isometry. All right. So maybe I can keep this on the board if I just do that. Number 1. Okay. So we got angle PQR there. Now technically we're going from the black image to the red image because it's P to P prime, but it doesn't really matter what order you think of it. So what kind of transformation is that?
Translation.
It's translation. It's just sliding over. That's all it's doing. Starts off with the translation. Okay. Number 3. What's happening on that one?
Shrinking.
It's shrinking, but what?
Translation.
No. No.
No.
None of the above.
It feels like dilation.
Okay, yeah, it's a dilation, which is not an isometry. We're not supposed to know the dilation thing yet. So, when I read the directions, it said identify any that are not an isometry, so this would be that. Not an isometry. Yeah, all the things that we've done so far have not made the image bigger or smaller. That is not isometry. 5 is kind of silly. It's just the line segment is just staying right where it's at, so it's not really doing anything. I don't really care if you know this one, but the book put identity, as in it just keeps its identity. It just stays what it was. Okay, speaking of not too concerned about, number 7 and 8 are asking about which of the 4 transformations preserve orientation. So orientation means everything is the same distance and direction, like the same direction from what it was. The only time, that doesn't happen on a reflection, because everything is backwards from what it was, it flips the image. So the 2 reflections do not keep their orientation. Everything's kind of backwards. So on number 7, the ones that do keep their orientation are these 2, rotation and translation. And the 2 that do not, number 8, do not keep their orientation would be reflection and glide reflection. Crisscross. Do. There's kind of a reason we're not using this book a lot, this chapter, because it's a bit of a mess on this one. All right, number 9, identify each transformation as a reflection, translation, rotation, or glide reflection. So on number 9, how do we get from triangle ABC to triangle ABC prime? What's happening there? Translation is just shifting over. That is a translation. Kind of repeat of number 1. It's a repeat of Monday and Tuesday stuff.
So it's just moving over?
That was number 9, yeah. So on number 11. Ooh. 11's tricky. Okay, 11 is moving over, but that's not the only thing that's happening.
Just the letters change.
The letters are changing. Like K is going to the bottom and J is going to the top. So how do you get that image to go? No. It's flipping. So it's a glide for the reflection because it's moving over and it's like swapping upside down. Okay, so that basically leaves you guys with like 2 options for the other 2, right? Because these are like the 4. Okay, 10 is not, you cannot get that image from a translation. You can't just shift it over because D and F are in the wrong corners. So something else is happening.
It has to be, they only get used once, right?
Yeah, it's flipping like a pancake. Yes. Yeah. Okay, 13. You guys can figure it out. All right, 13, a parallelogram. Okay, it says describe the image of each figure after the stated transformation. Parallelogram, and it's supposed to do a glide reflection. So if you like shift this image over and then flip it upside down. No, that's close enough. It looked kind of like that. So what happens to the parallelogram? Well, if I drew it right, it's still a parallelogram. It's just flipped. So all they did was put a congruent parallelogram. They're just trying to get you to see that it's not really changing what it is. Changing its direction and orientation. All right. 14. Okay, kind of, yeah. So what happens if you do one of these isometries to a ray? You guys remember what a ray was? Like if we reflected, for example, what would we get? Well, you would just get another ray. Okay, if you rotate it, if you reflect it, if you translate it, it's just still ray. Rays really can't be congruent because they are infinite things. So congruent doesn't make much sense on rays. Okay, 15 is drawings. So that green thing, it says copy each figure. So you might put your paper on top and like copy it. But make sure you leave yourself plenty of room. This green arrow is what the book is calling a vector. It's telling us which direction we're going to move the triangle, and we're supposed to reflect over that triangle. So we're going to translate and reflect the triangle. So if I was drawing it, I would put the triangle like up here in the upper right corner. Leave plenty of space. We don't have a lot of problems, so you guys shouldn't have to worry about space too much. Okay. The green line is telling us the direction and how far we should move the triangle. So, about yay far. So it should look something like this, X prime, D prime, Y prime. But then we are supposed to reflect over the vector. So this up here is going to flip down here. Remember when we did this reflection on Monday? Like how far it is from the line is how far the reflected point should be from the line. So if y is about this far, then the new y should be about that far from the line. Here's y prime. Z is about the same. X is farther away. Oh, this would be like double prime because that's like our third image. X double prime. Not too bad. So you can see why doing this on a coordinate plane like we did on the worksheets is a little easier because you can just count instead of having to kind of guess. Suppose you get a ruler out and be perfect, but. Are you guys good on 15?
Mm-hmm.
Alright, on 17, we're starting with angle ABC. And there's a vertical vector going down. A prime, B prime, C prime. Okay, then I'm going to reflect over that line. C is kind of close, so well, yay far. C double prime. A and B are farther away, so A is going to go way over here. A double prime and B is also kind of far away. Pretty close, not bad. Last two are on graph paper. So you guys need to, you're welcome. You please stop writing paper and stealing people's bags.
I'm sorry.
You can memorize the Ten Commandments.
Did you?
It's done by heart.
Keep her bed.
You guys can do it even right away. I'll be with you shortly.
Oh! My gosh, my brain is not working. Yes. Let's see.
Let's hope.
I should not.
Thank you.
Alright, to the graph paper. So, I'll explain it in a second. I'm just going to start by graphing the points they gave me on 21, Q, R, and S. So Q, -1, -1, that means left one, down one. R is -4, -2. And S is -2, -3. lesson. I almost said your face gets on my nerves, but I did not. Just kidding, just kidding.
I quit.
Right after we had that lesson about
That happened.
controlling your,
So,
controlling your
Kay said,
sleep.
say this Kay and Miss Bear's like, what about Kay? I said, Kay says it's sane. And I said, I didn't even think about it. It just happened. And then Marcus like, think before you speak, Lauren, because he just learned about it.
It's kind of hard to think about what whatever she
You have to think to speak in the first place. You have to think more about it, I
It's
guess.
kind of hard to
So I didn't think.
Okay, so let me explain this. So this is describing the vector 0, 4. This tells us what direction we're supposed to move. It's kind of like the problems we were doing. This describes the direction they want us to move the thing. So what do you think 0, 4 means?
0, stay where you are.
Means not moving right or left, up 4. Kind of like if you were to graph the point 0, 4, you go up 4 and put a dot. So basically they want us to move our graph up 4. And then they put comma y-axis because that's the line we're going to reflect it over. So I'm going to move these dots up 4. So this is more like the worksheet thing we did. Why does the AC turn on in the morning and not the afternoon?
Why is it so quiet?
Taunts me. Everybody's busy. Also, Brian's not here.
R.I.P. Brian.
R.I.P.
What are you doing?
Speaking of which,
What?
how's he doing anyways?
Honestly, I haven't been texting you, so.
Owen, like,
You haven't texted him recently, is that what you
someone
said?
told me
No,
he
I
had
just
skin
never seen
cancer.
He started doing like wrestling or something.
Yeah, he started wrestling, so now.
Okay,
Longest turns.
we're gonna reflect over the y-axis. So remember, Q is just 1 away from the y-axis, that's this one. So Q double prime is gonna be 1 away. R is like 4 away, so it's gonna go over here. S is 2 away. Okay, on 22, the vector says, whoops, 3, 0. So what would that mean?
Right 3.
Yeah, they want you to move the image right 3 and then flip it over the x-axis, the other axis. So it's going to be kind of messy because it's going to be on top of itself more than this one was not nice and neat. But you're going to have an image on top of itself when it flips, especially. But yeah. So graph those 4 points on 22, move them all right 3, flip over the x-axis.